Is reality real? Or could we be living in a sophisticated simulation? Could the universe be more like a dream than we ever imagined?
Remember, you are the dreamer. You build this world.
How can science help us answer these questions? Welcome to the simulation hypothesis.
Have you ever had a dream, Neo, that you were so sure was real? What if you were unable to wake from that dream? How would you know the difference between the dream world and the real world?
What if you woke up one day and discovered that everything you've always taken for granted is not what it seems at all? What you thought was reality is actually a simulation, a very complex, sophisticated illusion that you live inside of. Even solid matter itself is no more real than, say, a rock that you would pick up in a dream. And not only are you living in a simulation, but it's being generated by a system that you can contact with your mind and actually change the simulation itself, in effect, hacking the universe. What would you do to change the world? Well, recent scientific discoveries are strongly suggesting that this is the case, that we live inside a simulation, and that we, as observers, have a demonstrable power over it. We are actually participating in the creation of the reality that we live in. Wait, what? Are we really living in a simulation? Well, this is the conclusion that physicists and cosmologists have been coming to. And although this idea would have been ridiculed in the recent past, it is now being taken very seriously. Cutting-edge physics experiments have been producing some very strange results. Results that say our universe isn't an objective reality, but that it's actually emerging from something else, something non-physical and beyond our senses. In the digital age, science is beginning to see a correlation between our world and the world of a virtual reality.
The Matrix is everywhere. It is all around us. Even now, in this very room. You can see it when you look out your window or when you turn on your television.
Plato versus Democritus? What do these guys have to do with anything? I thought we were talking about science, not philosophy. Well, all scientific inquiries are based on one or more philosophical positions. So let's quickly go over some of the philosophical arguments that different scientific approaches are built upon. Ancient Greek philosophers already had the basic idea of the atom, and they used this idea to help them explain how reality worked. Out of all their various conversations, several very different views emerged. These views are best expressed in the works of Plato and Democritus. Democritus built his philosophy of materialism on the assumption that atoms are eternal, indestructible, and are the only things that really exist. All other things exist, said Democritus, only because they are composed of atoms. Following this logic leads you to believe that consciousness is a product of physical processes in the brain. This is the philosophical assumption that Isaac Newton, Charles Darwin, and most Western scientists until very recently built their work on. Plato built his philosophy of idealism on the assumption that the basic underlying structure of everything isn't the atom, but abstract mental forms that determine an object's properties. Plato believed that ideas are more fundamental than objects. For instance, a perfect or ideal sphere exists only as an abstract mental form or idea. Any sphere that we see in the world, like a basketball, is simply an approximation of the ideal sphere. By following this logic, you come to believe that consciousness is primary and gives rise to all physical matter and process. In other words, everything begins with consciousness, and there is a mind behind what we experience as physical matter. In much the same way that when you dream, Your mind is creating a physical experience for you while you sleep. As you can see, these philosophies are mutually exclusive, and are in fact opposites. Both cannot be true. Either mind gives rise to matter, or matter gives rise to mind. It's a very, very old debate, but science has finally harnessed enough power to settle it once and for all. The scientific hypothesis that our world is virtual, or dreamlike, has been explored in depth by many scientists, including Dr. Brian Whitworth. He took the two opposing views, one being materialism, that our universe is entirely physical, exists in and of itself, and needs nothing outside of it to explain it, and the other being the simulation hypothesis, that our universe exists as a virtual construct, and depends on information processing happening outside of space-time. Dr. Whitworth looked at all the facts that have been gathered from experimental results and asked which view better fits these facts. After a thorough analysis, his conclusion was that the data much better fits the simulation hypothesis.
Right now, we're inside a computer program?
Scientifically, our universe simply makes more sense when viewed as a virtual construct emerging from consciousness, rather than simply matter existing independently of the mind.
This isn't real.
What is real? How do you define real?
The analysis starts at the beginning, with the Big Bang. This well-established cosmological model demonstrates that space-time was created by a single event billions of years ago, and expanded into what we see around us today. Nearly all scientists agree that our universe began to exist at one point in the distant past. From the materialist view that our universe is all there is, as an objective, independent reality, the fact that the Big Bang came from nothing is very hard to explain. How could everything come from nothing? But if you look at the universe as a virtual construct, the Big Bang model works perfectly. Virtual worlds always begin with an information influx from a zero state, since they need to initially boot up. Every time a computer game starts up, a Big Bang occurs from the perspective of the game. From inside the virtual world itself, the creation always comes from nothing, because before it boots up, there is no space or time as defined by the rules of that virtual world. Another thing to consider is quantum bits. The fact that light is quantized as photons, electricity as electrons, etc., better fits the hypothesis that we live in a virtual construct. Because in digital processing, all data must have a minimal quantity, represented by bits or pixels, and our world displays the same property. Every computer-generated image breaks down into pixels when examined closely. And this is what science has found in nature. In the past century, physicists have discovered that matter really is quantized, composed of fundamental, indivisible particles billions of times smaller than an atom. And, as science has discovered more and more about the way the universe behaves, it has become clear that nature is a matrix of computable bits. Space is quantized, time is quantized, energy is quantized. Everything is made of individual bits, which means the universe has a finite number of components, which means it has a finite number of states, which means it's computable. If the true nature of the universe is indeed digital, that we do in fact have quantum bits of space and time, and that there's nothing that you cannot compute, and at the moment there is no evidence against this, then it's entirely consistent with the simulation hypothesis. Well, how does living in a virtual reality benefit me? Do I get superpowers? Can reality be hacked? Can we reprogram nature and take control of our experience? Are we, in a sense, already doing this, but simply unaware of it? Okay, for the sake of argument, let's say the data does fit the simulation hypothesis better than it fits materialism. That's all well and good. But is there any solid evidence of computer programming in nature? It seems there is. theoretical physicist James Gates has actually found computer code hidden deeply in the equations that describe supersymmetry.
So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos?
Into the equations that we want to use to describe the cosmos, yes.
Computer code.
Computer code, strings of bits of ones and zeros.
It's not just sort of resembles computer code, you're saying it is computer code.
It's not even just is computer code, it's a special kind of computer code that was invented by a scientist named Claude Shannon in the 1940s.
So are you saying we're all just, there's some entity that programmed the universe and we're just expressions of their code?
Consider the fact of a maximum speed in nature, the speed of light. In 2011, scientists reported neutrinos traveling faster than the speed of light. But those findings were retracted when it was discovered that equipment used in the experiment was faulty. Nothing has ever been seen to travel faster than the speed of light. Nature has a maximum speed, and events in a virtual world would also obey a maximum speed since they would be limited by a finite processor. There's also the curving of space by massive objects and time dilation at very high speeds. Both phenomena correlate to virtual processing load effects. High matter concentrations in our universe may constitute a high processing demand, such that massive objects would slow down the information processing of space-time, similar to the way that high data demands in a computer will slow down the processing speed. Every digital symbol created by the same program is identical to every other in the same class. In computing terms, objects are simply instances of a general class. The fact that all quantum objects are identical in each class, photon, electron, etc., correlates to a digital equivalent, since in a virtual world, every digital object created by the same code is identical. While the objects we see in our world have individual properties, the quantum bits that they are built from are all pressed from identical molds. The simulation hypothesis suggests that this is the case because each bit is created by the same program. Taken together, all of this might constitute what the courts refer to as sufficient weight of evidence, favoring idealism in the simulation hypothesis over materialism. When coincidences continue to pile up and combine with explanatory power, it presents a very strong plausibility argument, or even a proof. But even more convincing evidence is provided by cases that the simulation hypothesis can easily explain, but which materialist models have tremendous difficulty with. One such case is non-locality.
Toto, I have a feeling we're not in Kansas anymore.
For materialism to be true, and the world to exist independently of mind, the concept of locality is necessary. This means that for objects to interact, they must be in close proximity. This is what Albert Einstein believed for most of his life. To understand quantum entanglement and non-locality, we should take a look at Einstein's life and his role in the development of quantum mechanics. In 1905, horses still mingled with cars in the street, Ty Cobb was a major league rookie, and Albert Einstein was a low-ranking clerk in the Swiss Patent Office. That year, in his spare time, he wrote 4 remarkable scientific papers. The first established the photon as the particle associated with light, overturning many years of understanding light as a purely wave-like phenomenon. He used this new description of light to explain the photoelectric effect. In another paper, he mathematically proved the existence of atoms, something that was still debated at the time, and he actually calculated their size. He introduced his special theory of relativity, which describes how motion can affect the passage of time. And then, with E equals mc squared, he established the fundamental relationship between matter and energy. This explains what makes the sun shine. He was so far ahead of his time that no one even recognized his accomplishment. That is until this man, Max Planck, the greatest theoretical physicist in Europe at the time, and the editor of the journal Annalen der Physik, read the paper Einstein had submitted describing light as consisting of photons. Planck sent an assistant to the patent office to fetch Einstein. This recognition helped get young Albert accepted into the University of Zurich. Max Planck made many important and lasting contributions to the field of physics, but perhaps his greatest discovery was Einstein. This bright young chap is Niels Bohr. He grew up in Copenhagen, Denmark, and received his PhD by age 26. Not too shabby. He studied Einstein's paper proving the existence of atoms, and in 1913 he introduced a conceptual model for the workings of the atom, and it's still the one taught today. A positively charged nucleus is orbited by negatively charged electrons, and these electron orbits have very specific energy levels that are quantized. Bohr's atomic model had enormous impact on atomic physics and chemistry, paving the way for the modern era. He was given a nice position at the University of Copenhagen as a physics professor. Meanwhile, Einstein had been made a member of the Prussian Academy of Sciences and a professor of physics at the University of Berlin. Oh, and he's published a few more papers. In one of them, he answers the age-old question, why is the sky blue? He solved the problem by examining the cumulative effects of light scattering by individual molecules in the atmosphere. Just another day at the office. Well, it's the 1920s and every young boy wants to be Charlie Chaplin. This one wanted to be a scientist. His name is Werner Heisenberg. You may be familiar with his famous uncertainty principle, which sets hard limits on empirical inquiry. In 1925, he introduced a concept known as matrix mechanics in an attempt to explain how energy is absorbed by atoms. He did this by describing atoms not as actual physical objects, but as mathematical matrices that evolve over time. Matrix mechanics was very radical stuff, and it didn't look like traditional physics at all. Niels Bohr accepted Heisenberg's ideas as valid. But most other physicists, including Einstein, thought of them as something of a fad that would fade away once a better theory was found. Heisenberg became a professor himself and started to spread his own ideas. This is Erwin Schrödinger. In 1926, he was teaching physics at the University of Zurich, where Einstein had gotten his PhD. He wrote a paper introducing wave mechanics as an alternative to Heisenberg's matrix mechanics. It was Schrödinger who first claimed that two particles could be entangled and that they would behave as one system, as one thing, mind you, even if they were separated in space. This meant that any interaction with, observation, or measurement of one of the entangled particles would cause an instantaneous effect in the other, even at great distances across space, up to and including infinite distance in space. This is what is known as non-locality. For the majority of physicists, who were, after all, completely invested in a materialist view of the universe, this was truly unacceptable, and simply could not be true, even if all the equations worked. They just needed to put their heads together and figure out what was really going on with this newfangled wave and matrix mechanics. Einstein took particular interest in this problem because it was he who had let the genie out of the bottle with his photon and the quantum theory of light. The 1927 Solvay Conference was held to solve these new problems in defining the properties and behavior of photons and electrons. Talk about some heavy hitters. Of the 29 people pictured here, 17 won Nobel Prizes. Here is Madame Curie, next to her is Max Planck. Here is Einstein, who by this time had overturned Isaac Newton's theory of gravity with his own general theory of relativity, and he was by far the most famous scientist in the world. Here are the young upstarts, Erwin Schrödinger and Werner Heisenberg, the ones who started all this trouble. And here is Niels Bohr, caught in the middle between the youngsters and the older traditionalists led by Einstein. During the conference, Bohr and Einstein began a discussion about the true nature of reality that would become the greatest rivalry in modern science. Bohr's position was that the new quantum theories would prove to be true, that they were the path to the future. But Einstein insisted that this was impossible, that quantum theory simply could not be an accurate description of the universe. Following the conference, Einstein began work on what he called a unified field theory that would eliminate the need for quantum mechanics and fully explain all of the weird phenomena that were being observed and described by the equations of the new quantum theories. Through the 1930s, Einstein continued to reject quantum theory as an inferior model of the universe when compared to materialism. And in 1935, he co-authored a paper with Boris Podolsky and Nathan Rosen to show that quantum theory could not be accurate because of the prediction of instantaneous interaction between quantum bits separated by space. The Einstein-Podolsky-Rosen paper was called "Can Quantum Mechanical Description of Physical Reality Be Considered Complete?" Einstein called the predicted non-local behavior of particles spooky action at a distance, to drive home the ridiculousness of such a prediction. The 1940s were a good time for Einstein. He continued to bask in his rock star celebrity, living in Princeton, New Jersey, teaching at the Institute for Advanced Studies, and collaborating on several important papers. But all the time, he was trying to win the argument with Niels Bohr, working away at his unified field theory to rescue the materialist universe from quantum non-locality. By 1955, Einstein was an elderly man. He had been working on his unified field theory for 28 years to no avail. This was the man who had written 4 groundbreaking scientific papers in a single year. He had explained why the sky is blue, what makes the sun shine, how acceleration through space can slow down time. He overturned Newton's theory of gravity, and many, many more accomplishments. But now he had spent nearly 3 decades trying to salvage materialism and was unable to do so. Albert Einstein passed away on April 18, 1955. In 1962, Niels Bohr died, his conflict with Einstein still unresolved. Then, in 1964, the Irish physicist John Bell proposed his famous theorem. It's a very clever mathematically based way of experimentally testing and proving one way or the other who was right. Doing the experiment would require some very special hardware. It took 18 years for this technology to become available, and in 1982 the physicist Alan Aspect put it all together and ran the experiment. The results confirmed that non-locality was actually real. What Schrödinger had called entanglement, and was defended by Bohr but ridiculed by Einstein, was a fundamental property of nature. Instant correspondence can be seen between 2 particles that are separated by unlimited distance in space, and this only makes sense if the world is a virtual construct. In a virtual world, distance doesn't limit correspondence, since all points in a simulation are equidistant with respect to the source of the simulation. For example, in a computer game, all points on the screen are at equal distance with respect to the processor, and the same effect can be seen in our world. If our universe is a simulation projected onto a 3-dimensional screen, then its processor would be equidistant to all points in the universe. Non-locality, one of the biggest problems in physics, is easily solved by the simulation hypothesis. Space seems to be an illusion created by the virtual construct. But even stranger than space being an illusion is what quantum physics tells us about matter itself.
If I were a character in a computer game that were so advanced that I were actually conscious and I started exploring my video game world, it would actually feel to me like it was made of real solid objects, made of physical stuff. Yet if I started studying as the curious physicist that I am, the properties of this stuff, the equations by which things move and the equations that give the stuff its properties, I would discover eventually that all these properties were mathematical. The mathematical properties that the programmer had actually put into the software that describes everything.
The server that's creating you is not in your reality frame. It's outside. If you're Sims, that computer is non-physical to you. What's physical to you is your Sims world.
Prior to observation, matter does not seem to exist. Matter seems to be the result of an interaction between consciousness and waves of potential. This has been demonstrated repeatedly in ever more precise versions of the double-slit experiment, from the 1920s right up through the present. To understand the double-slit experiment, we first need to know how particles behave. If we shoot small objects at a detector, we will see a clump pattern form where they went through the slit and impacted. If we add a second slit, we would expect to see a second clumping duplicated to the right. Now let's look at waves. The waves go through the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the clump pattern. But when we add the second slit, something different happens. When the top of one wave meets the bottom of another, they interfere and cancel each other out. This results in an interference pattern on the back wall. Where the waves reinforce each other, they are at the highest intensity, the bright lines. And where they cancel each other out, there is nothing. So, when we fire objects through two slits, we get two clump patterns. But with waves, we get an interference pattern. An electron can be seen as a very small bit of matter. And when a stream of electrons is fired through one slit, they behave like small objects, forming a single clump pattern. So if we fire these bits of matter through two slits, we should get two clump patterns. But we don't. We get an interference pattern. We fired particles through, but we get a pattern like they're waves, not like little objects. How can pieces of matter create an interference pattern like waves? It doesn't make sense. At first, physicists thought that the electrons were bouncing off each other to create this interference pattern. So, in 1961, Klaus Johnson at the University of Tübingen in Germany modified the experiment to fire the electrons through one at a time. This way, there is no possibility of them bumping into and interfering with each other. But again, the interference pattern was seen. Physicists were perplexed by this.
It somehow seems to have been aware of there being two slits, not one, because it's given rise to this interference pattern. How does one atom do that? Does it split in half? Does it become like a cloud that goes through both?
The path taken by the photon is not an element of reality. We are not allowed to talk about the photon passing through this or this slit. Neither are we allowed to say that the photons pass through both slits. All this kind of language is not applicable.
So they further modified the experiment to get to the bottom of the mystery. They put a measuring device at one slit to see which one the particle actually went through. But when the electrons were being this closely observed, they went back to behaving like little objects and produced a clump pattern, not an interference pattern. Somehow, the act of observation meant that they only went through one slit, not both. The electrons seemed to decide how to behave as if they were aware of being watched. How could this possibly be the case? Could the presence of a conscious observer be influencing the experiment?
Consciousness is information. It's an information field. Okay? It's data.
In 1978, physicist John Wheeler proposed a new way of doing the double-slit experiment that might finally reveal what's really happening. He proposed what is called the delayed choice experiment, in which the decision of whether or not to observe the particles isn't made until after they have gone through the slits, but before they've impacted the detector. This animation is highly simplified, but you get the idea. Here comes the light. It travels through the double-slit barrier as waves. The waves are past the slits but haven't yet hit the detector. And here comes the scientist. His eyes are closed. He's delaying his choice to make this an observed experiment. And then... The results of the experiment didn't solve the mystery. Instead, it got even stranger. Because what was found was that at the moment of decision to observe, the waves became particles. And not only that, but they actually made a record of themselves as having traveled through the slits as particles. Yes, you heard me. Deciding to run the observed experiment causes the waves to become particles, and this causal force extends backwards in time.
Our choice of what experiment to do determines the prior state of the electron.
Running the experiment unobserved does not cause this effect. When John Wheeler first proposed adding the delayed choice protocol to the double-slit experiment, he asked us to imagine a distant star that emits a photon billions of years ago and sends it towards the Earth. However, on the way, it must pass a dense galaxy. Gravitational lensing will make the light bend around the galaxy. Billions of years later, upon reaching the Earth, an astronomer chooses to use a binocular-type detector and focuses half of it on the left side of the galaxy and half of it on the right side. How the astronomer chooses to measure means the photon could only have taken one path and would display a clump pattern. So how we choose to observe in the present determines how the photon behaved billions of years ago. What John Wheeler had predicted was confirmed by the experiment. This doesn't make sense in the materialist worldview. It only makes sense if the universe is a simulation and all parts are equidistant in space-time with respect to the source of the simulation, like in a video game or a dream.
The Force? The Force is what gives the Jedi his power. It's an energy field created by all living things. It surrounds us and penetrates us. It binds the galaxy together.
Max Planck famously said, "There is no matter as such. All matter originates and exists only by virtue of a force. We must assume behind this force the existence of a conscious and intelligent mind. This mind is the matrix of all matter." One of the hottest ideas in cosmology is known as the holographic principle. It's the idea that our three-dimensional universe is emerging from 2D information. That is, three-dimensional objects are composed of information spread out on a two-dimensional surface, in the same way that a hologram produces a three-dimensional image from two-dimensional information. The holographic principle tells us something very surprising. It says that our ideas of volume, and in a sense, the world, might be a kind of illusion.
First of all, I would say it should be clear that this whole holographic story is the most radical thing that has happened to our understanding of space, time, matter, since the invention of quantum mechanics and relativity.
Quantum theory in general, and the results of the experiments that have been run in this area, reinforce the holographic principle. Is there any test that we could do to scientifically prove that the universe is a virtual construct and not materialist in nature? Well, you may think that scientists would have run out of ways to do the double-slit experiment. But you'd be wrong. The delayed choice quantum eraser experiment was first performed in 1999 by Marlon Scully, Yoon-Ho Kim, and collaborators. Dr. Kim was consulted to ensure the accuracy of this presentation. The experiment begins in the top left corner with a photon source behind the barrier with two slits. A crystal is placed in front of the barrier which splits the photons into entangled pairs. This lens has the task of directing one of each pair, which have traveled through either slit, so that they will impact at detector 0. When a photon comes through the first slit and is split into an entangled pair, one of them flies through the lens and into detector 0. The second flies downward and is redirected by the prism into the green half-silvered mirror. Half-silvered means that they allow light to pass through 50% of the time. The other 50% are reflected. So, on average, half of the photons are reflected up and impact detector 4. The other half simply travel through, reflect off a full mirror, and reach another half mirror. They can either travel through it and hit detector 1, or be reflected into detector 2. Photons traveling through the second slit are also split up into pairs, with one traveling down and redirected by the prism. At the first half mirror, 50% are reflected and impact detector 3. The others travel straight through and are reflected into the second half mirror. 50% of these travel through and impact detector 2. The other 50% are reflected and hit detector 1. So, all the photons that came from the first slit on the red path could only impact detectors 1, 2, and 4. They can never reach detector 3. All photons coming from the second slit, the blue path, can only impact detectors 1, 2, and 3, but never detector 4. So any photons hitting detector 4 must have traveled through the first slit, and any photons hitting detector 3 must have traveled through the second slit. For photons that impact detectors 1 and 2, it is impossible to determine which slit they came from, because these two detectors can be reached from either red or blue path. The path of their actual origin has been erased by the experimental setup. So what is the function of detector 0? The results of the experiment are related to the time it takes the photons to travel through the apparatus. The shorter the path, the faster the photon reaches the detector, and the shortest path is always to detector 0. So when the photons are split up into pairs, one of them is always recorded at detector 0 first. And then, with a delay, the partner photon hits one of the other detectors. The coincidence counter records the results of all 5 sensors. It establishes a connection between the measurements at detector 0 with the partner photons that reach detectors 1 through 4. This way, each single photon registered at detector 0 can be precisely assigned to a partner at the other detectors.
Let's get ready to rumble!
This showdown was 2,500 years in the making, and it's for all the marbles, folks. They're playing for the entire universe. It's Plato versus Democritus. Idealism versus materialism. Head to head. Winner takes all.
Now, this apparatus can get moving along at a pretty good clip. So they fire a whole slew of photons through here, let the experiment run, gather plenty of data, and then run the analysis. And what are the results? Detectors 1 and 2 always show interference patterns because it's impossible to determine which of the two slits the photons came from. But detectors 3 and 4 always show clump patterns because we can know which slit these photons came from. That is the only difference. How the light chooses to display itself as particles or waves is dependent on how much we know about it. If it had to come from just one slit, clump pattern. If it might have come from either slit, interference pattern. There is no materialist explanation for this. But even more mind-boggling is that the photons know beforehand which detector they will hit. How do we know this? Because of how the twin behaves at detector 0. Because the path to detector 0 is shortest, one of the split pair registers here first, before its twin ends up at any other detector. And whatever registers at detector 0 always correlates with where its twin ends up. So if one of the pair hits detector 3 or 4, detector 0 always displays a clump pattern. But if its twin lands at detectors 1 or 2, detector 0 always displays an interference pattern. Can the particle predict the future? Or is space-time a virtual construct with all time frames available simultaneously at the source of the simulation? Modern physics has definitely decided for Plato. The smallest units of matter are, in fact, not physical objects in the ordinary sense of the word. They are potential forms. In Plato's sense, abstract ideas which can only be described in the language of mathematics. Space and time are ideas as well, not absolute properties of nature. Science has decided. Materialism is not a valid worldview. Most physicists now accept that particles do not exist as objects in the absence of observation, but exist only as waves, which then form into particles when observed. These waves aren't anything tangible like ocean waves or even radio waves, but simply a probabilistic description of where the particles might be if they were checked on.
Particles are probability distributions, not little hard things. But when you measure them, like measure which slit they go through, you get a particle.
The wave that forms into a particle is only a wave of potentiality. This is what Werner Heisenberg said many years ago. The atoms or elementary particles themselves are not real. They form a world of potentialities or possibilities rather than one of things or facts. When you look, they appear. When you're not looking, they don't necessarily exist. This situation seems very odd until you compare it to what you see in a computer simulation. A video game gives you the frame that you need when you're looking there. When you navigate around and look at something else, it creates and gives you that frame. Oddly enough, the universe behaves the same way. Our world really does seem to be pixelated, and it only assumes definite form when observed. The very same way computer simulations behave. This is why the simulation hypothesis is now taken seriously by an increasing number of experts.
I personally find that I gravitate more towards the information theoretic point of view and believing that the universe that I exist in is a very good, high-quality simulation.
Some folks have tried to salvage objective reality and materialism by claiming that the quantum realm operates on a separate set of rules that don't apply to the macro world of our daily experience. This idea is called macro-realism. The scientists Leggett and Garg proposed an idea similar to Bell's theorem, known as an inequality, to test whether there is a limit on quantum effects. But in 2011, a team led by Stephanie Simmons and George Nee experimentally demonstrated violations of the Leggett-Garg inequality. And these results have been duplicated many times since then, showing that macro reality emerges from quantum reality. So you can't separate the two. Reality is all emerging from the same source and operates by the same rules at all levels. The double-slit experiment has been successfully performed with larger objects such as atoms, molecules, and even buckyballs, spherical structures made of 60 carbon atoms. Scientists are currently designing experiments to do this with mid-sized proteins and viruses. Non-local entanglement has been recorded between pairs of small diamonds, aluminum chips big enough to be seen with the naked eye. A small metal paddle has even been placed into a state of non-local superposition. As of February 2015, macro-realism has failed every single experimental test. The fact that quantum effects exist at the macro level is what makes quantum computing possible. And quantum computing takes place on a daily basis at Dr. Seth Lloyd's MIT Qubit laboratory. The idea that you can prevent the downfall of materialism by claiming that the macro world is separate from the quantum world simply doesn't work. Reality is all emerging from the same source. So, is the quantum realm different?
No, no different. Only different in your mind. You must unlearn what you have learned.
Okay, fine. So the science says that we may really be living in a simulation. But what does that mean? Am I being kept alive in one of those scary pod things from the Matrix? Is my brain sitting in a jar somewhere with wires hooked up to it? Is someone else in control of my thoughts, feelings, and dreams? Why is all of this so mysterious and difficult to understand? Wouldn't a creator want me to know what's going on? Is the creator afraid to expose their true intentions? Is he hiding from us? Why? Why won't he reveal himself?
Pay no attention to that man behind the curtain.
What if part of your subconscious is still connected to the original consciousness that programmed this virtual reality? After all, we know that our subconscious can create a physical experience for us while we sleep.
Genuine inspiration, right? Now, in a dream, our mind continuously does this. We create and perceive our world simultaneously, and our mind does this so well that we don't even know what's happening.
I don't know a single scientist who would disagree with the statement that the world is exceedingly ingenious. Not just mathematical, not just beautiful, not just elegant, but the manifestation of something truly extraordinary.
Albert Einstein was one of the smartest people who ever lived. In 1 year, he wrote 4 of the most important papers in the history of physics and introduced sweeping changes that ushered in technologies ranging from lasers to the global positioning system. At the end of his life, after spending 28 years searching for a unified field theory built on materialism, Einstein seemed to change his mind about the fundamental nature of the universe.
Is everything here created by God? Well, yes, if God's the larger consciousness system, yes.
If we can all agree on one thing, it should be that science means discovery.
That's good. You've taken your first step into a larger world.